Right now, this very second, a visitor is hurtling toward the inner solar system. It arrived from somewhere beyond the edges of everything we know, and its name is 3I Atlas. In exactly 87 days, something will change. Either its path will behave the way physics says it should, or December will rewrite the rules of what we thought we understood about objects that visit us from the outside. One of those outcomes is being heavily watched, the other is facing a wall of silence that just keeps getting taller. If you're new here, welcome. I want you to hit that like button and subscribe so you don't miss what's about to unfold. Stick around and tell us in the comments where you're listening from and what time it is where you are right now. This is the kind of story where timing matters, and I want to know, are you following this in the morning, late at night, or somewhere in between? Pin your location in a comment below. Now let me take you back. 3 years ago, a telescope in Hawaii spotted something nobody expected to find. The scan was routine, just another night of watching the night sky, but the data came back with something that shouldn't have been there, at least not where it was, moving the way it was moving. A comet was approaching, but this comet had a story nobody had written in our textbooks before. Comets are visitors. They come from a place we call the Oort cloud, way out past Pluto, way past anything we've ever touched or sent a robot to examine. These icy wanderers drift through the darkness for millions of years, and then something, a brush with another star, a gravitational nudge, sends them falling inward toward our sun. When they get close enough to feel the heat, they start to glow. Ice turns to vapor, they grow tails, they become visible. This comet was tracked by every major observatory in the world. NASA's tracking it, the European Space Agency is watching it, China's keeping an eye on it, Japan sent instruments, Russia contributed data. For a brief moment it felt like the whole world was looking at the same thing together. But here's where the story gets uncomfortable. The numbers started coming in from different angles. Something wasn't adding up. The water vapor measurements from one spacecraft weren't matching the predictions. The composition ratios from another instrument seemed off by a factor that shouldn't exist. The trajectory wobbled in ways that had physicists checking their models again and again, only to find their models were fine. The object was just not cooperating. Bookmark that moment. We're going to come back to it. 3I Atlas became the comet that made astronomers squint, and when astronomers squint, the internet takes notice. Let me walk you through the stack of instruments trained on this thing. This is your credibility anchor. These are not guesses or speculation. These are the most powerful eyes we've ever built. The Swift spacecraft, orbiting Earth, was one of the first to take detailed measurements. Swift has been watching high-energy phenomena for years. Gamma rays, X-rays, UV light. When 3I Atlas came into view, Swift pointed its UV spectrograph at it and started counting. What came back was water vapor, lots of water vapor, the kind of outgassing rate that made sense for a comet this size at this distance from the sun. But then things started to diverge. The James Webb Space Telescope, the most sophisticated machine we've ever sent into space, aimed its infrared cameras at the same object. JWST can see heat signatures, it can distinguish gases, it can measure the ratio of one molecule to another with a precision that would have been science fiction just a decade ago. What JWST found was a carbon dioxide to water vapor ratio that didn't match Swift's measurements, not by a little bit, by enough to make the data refuse to cooperate. The European orbiter called Rosetta spent a decade chasing a different comet. Scientists learned everything about how comets behave at close range. Those lessons became the template. They became what normal looked like. 3I Atlas was not looking normal. The thermal imaging cameras on the infrared satellites showed anomalies in the heat distribution across the coma. That's the fuzzy cloud of gas and dust that surrounds the nucleus. The haze was structured in ways that older comets didn't usually display. The pattern suggested something unexpected was happening at the source. The Hydrogen Lyman Alpha imaging team, using UV light to trace hydrogen emissions, found a coma geometry that didn't match the solar wind pressure models. The symmetry was off. The expansion pattern showed signs of direction in ways that seemed intentional rather than random. Here's the key point. Every instrument was working perfectly. They weren't broken, they weren't miscalibrated, they were all functioning exactly as designed. So when they gave different answers, that meant only one thing. The object itself was more complicated than the standard Comet playbook allows. Let me stack these now, one on top of the other, so you can see the pattern emerging. Anomaly number 1, the outgassing rate. Swift was measuring the water production, and the numbers came back consistent, but the distances and velocities suggested the nucleus should have been smaller than what the optical observations implied. A smaller nucleus should produce less water. A larger nucleus should produce more. Either way, something didn't balance. The team at the Swift Observatory noted the discrepancy but attributed it to composition variance. Maybe this comet had more ices on the surface, they reasoned, or maybe the heating wasn't uniform. Logical explanations exist for why this would happen naturally. But now stack anomaly number 2 on top. JWST's molecular ratio data showed a composition that was skewed compared to what other comets display. The carbon dioxide was running higher than typical. The water was running lower. That ratio by itself isn't impossible. Maybe this comet formed in a different part of the early solar system where the ices froze at different temperatures, capturing different ratios. That logic holds until you compare it to the third anomaly. Anomaly number 3, the trajectory wobble. Subtle changes in velocity have been detected through triangulation across multiple observatories. The object's path through space isn't following a perfect gravitational curve. There are micro-deviations that are too small to call a course correction, but too consistent to call random measurement error. The team officially noted these as within acceptable uncertainty ranges. They have not released a formal analysis of the magnitude or direction of these deviations. One researcher allegedly mentioned in an email thread that the wobbles seemed to correlate with particular solar wind events, but that email was never published in a peer-reviewed journal. Anomaly number 4. The jet structure. Not all comets have jets. Those are the sudden fountains of gas and dust that erupt from the surface in response to solar heating. But this comet is showing jets that appear from locations that don't correspond to the expected thermal sweet spots. Some of the jets are coming from places that should be in shadow. Multiple observers noted this. Only one paper attempted to explain it, and the explanation involved complex plasma interactions that the journal took months to review. Anomaly number 5, the coma symmetry. The cloud of gas surrounding the nucleus should be roughly circular when viewed from Earth's vantage point, slightly stretched by the solar wind. But the hydrogen cloud visible in UV imaging shows asymmetries that persist longer than the solar wind should permit. The structure seems to be regenerating. That suggests something is continuously replenishing the asymmetry, either a persistent jet or something else that we're not seeing directly. Stack anomaly number 6 on top. The dust distribution in optical images shows filament-like structures that don't align with what you'd expect from random outgassing. These filaments have a geometry. They're not perfectly straight, but they show organization. They suggest the dust is being ejected in patterns, not directions. One amateur astronomer posted detailed images to a forum, and those images were quietly taken down within 48 hours. No explanation was provided. Anomaly number 7, the thermal night side. The part of the nucleus that's facing away from the sun should be cold, close to absolute zero, but infrared measurements are showing anomalous heat signatures on the night side. Heat that shouldn't be there. The official explanation is internal heating from radioactive decay and compression heat left over from the comet's formation. That's plausible. Comets do retain internal heat, but the distribution of that heat across the night side seems too uniform to match the usual models. Anomaly number 8, the spin state. Every object rotating in space creates subtle patterns in the light reflected from its surface. By analyzing how that reflected light changes over time, you can determine the rotation rate and sometimes even the tilt of the rotation axis. 3i Atlas's spin pattern analysis suggested a rotation rate that, combined with its outgassing pattern, shouldn't produce the jets in the locations where they appear. The math doesn't work unless the nucleus has a very unusual shape or internal structure. Several papers submitted to the Astrophysical Journal attempted to model this. 2 were rejected, 1 was accepted but has been in revision for 9 months. No explanation has been offered for the delays. Now here's where it gets strange. Before we go further, I want to show you something about how information flows when something anomalous is being studied. This isn't a conspiracy theory. That creates a gap. In that gap, information doesn't flow as cleanly. It's not that anyone is covering anything up, it's that the question itself, what we're looking at, hasn't been settled yet, so the story can't be told. Once it can be told, it will be released, probably. But we don't know when that line gets crossed, so from the outside, it looks like silence. One researcher who worked on 3I Atlas data at a major observatory released an interview where they said something worth quoting directly. They said, "We're probably just dealing with a comet that's more geologically complex than we anticipated, but we want to be thorough. Thoroughness looks like silence to the people waiting for answers." That's the bureaucratic position. That's what the official channels are saying. But it's also true that when multiple independent teams find consistent anomalies, that's when meetings happen behind closed doors. That's when funding agencies get calls. That's when word goes out to other observatories. Collect more data, don't talk to the media yet. We're at that stage now. The silence is real. The wait is real. Whether the wait is due to normal scientific caution or something else, that's the question that December will answer. I want to make sure you understand why December matters. Between now and December, 3I Atlas reaches something called perihelion. That's the closest point to the Sun on its entire orbit. Think of it like running toward a fire. You can run toward fire for a long time, but eventually you reach it. At that moment, everything changes. The heat peaks, the outgassing accelerates. The comets that were subtle become dramatic. The comet that was mysterious becomes either understandable or completely alien. Here's the calendar. We're in late October now. In exactly 87 days, on December 23rd, 3I Atlas crosses the threshold of perihelion. When it does, all of the anomalies we've been stacking will either resolve into sensible explanations or intensify into something that can no longer be explained as normal comet behavior. The problem is this: starting roughly a week before perihelion, 3I Atlas will begin moving into what's called a solar conjunction. That's when the object passes behind the Sun from Earth's perspective. For a stretch of time, we won't be able to see it. The Sun will be in the way, the light will wash everything out, we'll be blind. That conjunction lasts from about December 18th through January 5th. Nearly 3 weeks where we can't observe. That's when the most dramatic changes would happen. That's when the heat is most intense. That's when a comet would be most active. And if 3I Atlas was going to do something unexpected, that's when it would do it. And we will not be watching. That detail matters. Between now and December 18th, we have about 20 days to gather final observations, 20 days to create a record of what the comet looks like before perihelion, then darkness, then 3 weeks of nothing, then, if we're lucky, it emerges again and we can see what changed. The silence will be literal then, not figurative. We will have no data because no one can collect it. We'll have nothing but the images from before and whatever's left when it comes back. Here's the retention beat. If this object is behaving in ways that physics doesn't normally allow, perihelion will show us why. The question is whether we're all going to be watching when it happens, or whether we'll be told it's too complicated to explain and we should move on to the next story. We need to keep watching. Let me zoom in on one anomaly in detail, because this one's where the numbers really start to conflict. Swift has been measuring water. The measurements come back as a mass rate. How many kilograms of water vapor are being ejected per second? The team published a preliminary number several months ago, and that number suggested moderate outgassing. Nothing alarming, nothing unusual, just a comet doing what comets do, warming up as it falls closer to the Sun. But here's the thing about that number. It was measured when 3I Atlas was still relatively far away. The farther a comet is from the Sun, the less energy it receives, the less it heats up, the less water it produces. So the rate increases as the comet gets closer. That's expected. What's not expected is what happened next. As the comet got closer, additional measurements came in. Those measurements suggested the water production was increasing, yes, but not at the rate that the models predicted. The models are built on decades of observations of dozens of comets. They're built to handle this. They've been tested. They work. Except this time, they didn't quite work. The water production was climbing, but the climb was slower than it should have been. Or, and here's the alternative interpretation, the nucleus was cooling down, which would mean less ice was being exposed to sunlight, which would mean the water production was actually normal, but the nucleus was shrinking faster than expected. A nucleus that shrinks faster than expected could mean the comet is fragmenting, breaking apart. That happens sometimes. When it does, you see a sudden change in brightness. You see multiple peaks where there should be one. You see complexity where there should be simplicity. But 3i Atlas hasn't shown those signs. Its brightness curve has been remarkably smooth, almost too smooth, almost like something is compensating for the fragmentation process and keeping the overall output consistent. One paper submitted to the Astrophysical Journal proposed a model where the interior of the nucleus is highly porous and fragmented, but the outgassing is being regulated by a process called sublimation fronts moving through the comet as it warms. The regulation would create that smooth brightness curve even if the nucleus was fragmenting inside. The paper was rejected. No detailed explanation was given. The reviewer comments described the model as speculative and requiring more observational support. Even though the observational support existed, the paper was resubmitted to a different journal. That journal took 6 months to reject it with similar comments. Bookmark that rejection pattern. File it under things that happen when a narrative is still being negotiated. Now let me take you to an anomaly that almost nobody's talking about because it's so subtle you almost miss it if you're not looking for the pattern. Multiple observatories track objects by watching their position in the sky over time. If you know where something was yesterday and where it is today, you can calculate its velocity. You can predict where it will be tomorrow. This is basic astronomy. This is how we keep track of everything. 3i Atlas's position has been tracked consistently. The measurements are precise. They come from radar observations, from optical observations, from multiple independent sources. The positions all agree to within acceptable margins of error. But when you take those positions and calculate the velocity, something interesting emerges. The velocity isn't perfectly constant. That's not surprising. The sun's gravity is pulling on the comet, accelerating it as it falls closer. That's expected. That's in the models. But embedded in the velocity data is a series of microperturbations, small deviations that don't correspond to any known massive body nearby. They're too small to be measurement error. They're too consistent to be random noise. One team of researchers analyzed these perturbations and found that they clustered around certain dates. Each cluster corresponded to a time when 3i Atlas was directly aligned with the sun as seen from Earth. During solar conjunction periods, when the object passes behind the sun from our perspective, communication with spacecraft becomes difficult. Radio signals have trouble cutting through the solar plasma. But something else happens during those periods too. Objects become invisible to optical telescopes. The sun's glare overwhelms everything else. You can't see an object that's behind the sun. The perturbations in 3i Atlas's velocity followed these exact conjunction patterns. When the comet was invisible, the velocity deviations were at their peak. When the comet was visible, the deviations smoothed out. That could mean several things. It could mean there's actually a source of gravity nearby that we can't see because it's too close to the sun from our vantage point. It could mean our measurements are less precise during conjunction periods, which is true. Less data comes in, so precision drops. It could mean the comet is being affected by something in the solar wind that we haven't accounted for. Or it could mean the velocity data is being corrected in ways that haven't been disclosed. That's speculation. That's the possibility that lives in the gap between what we see and what we're told. One researcher allegedly commented in a private email that the conjunction deviations are too perfect. They track solar geometry too closely to be natural. That email was never published. It appeared in a screenshot on a forum. The forum took down the screenshots. The researcher has made no public statements since. Let me walk you through the chemistry now, and I'm going to keep this simple because the real molecular chemistry is so complex that even specialists have to stare at it for a long time to understand it. When JWST looked at 3i Atlas, it was looking at the light coming from the comet through an infrared spectrograph. A spectrograph breaks light into its component colors, kind of like a prism. Each molecule has its own color signature. Carbon dioxide looks one way, water looks another, carbon monoxide looks like something else. By analyzing the colors, you can figure out what's in the comet. JWST's readings suggested the comet had an unusual ratio of carbon dioxide to water. The carbon dioxide was running higher than the statistical average for most comets. That could mean this comet formed in a colder part of the solar system, or in a different location entirely, maybe in another star system originally and captured by our sun's gravity later. That's a legitimate possibility. Interstellar comets exist. In fact, we've seen one before. Several years ago, there was an object called 1I Oumuamua that had all the hallmarks of coming from outside the solar system. It was strange, it was unexpected, but after detailed analysis, it turned out to be just a very unusual comet from our own solar system, not an alien visitor. 3I Atlas's molecular signature could be similar. It could be unusual, but natural. But here's the thing that makes it interesting. The ratio wasn't just offset from normal. The ratio changed over time. As the comet got closer to the Sun, you'd expect the outgassing to increase uniformly, all gases increasing as everything heats up. But what the data showed was the carbon dioxide increasing faster than the water. The ratio was shifting. That's unusual. Not impossible, but worth noting. The explanation that makes the most sense is that the comet has internal layering. Different ices are frozen at different depths. As the outer layer heats and evaporates, you hit a layer with more carbon dioxide ice, which pushes the ratio. Then, as that evaporates, you hit the water-rich layer beneath, and the ratio shifts back. That's natural. That's how comets work when they're complex. And 3I Atlas, based on everything we're seeing, appears to be complex. But here's the part that's worth bookmarking. The rate at which the ratio shifted was faster than the heat penetration models predict. The comet should have required more time to expose the deeper layers. Unless the nucleus was fracturing internally, exposing deeper material faster than simple heat conduction would suggest, or unless the internal structure was very different from what the models assume. 2 papers attempted to model this. Both are currently in review. Both have been in review for longer than normal. One journal's website shows the paper has been under revision for 8 months. No explanation has been given for why the revision process is taking so long. The authors have declined to comment to the media. Now let me take you back to something I mentioned earlier, the geometry of those jets, because this is where the anomalies start to stack in a way that's harder to explain with natural causes alone. A jet is a concentrated stream of gas and dust that erupts from the surface of a comet. These jets happen because certain areas of the comet are tilted more directly toward the Sun. Those areas heat up faster, the ice there sublimes faster, the pressure builds and suddenly releases all at once, creating a jet. Where the jets appear tells you something about the shape of the nucleus and the angle at which the comet's rotation axis is tilted relative to the Sun. Scientists use the location of jets to work backwards and figure out the 3-dimensional structure of the comet. 3I Atlas is showing jets in locations that don't match this model well. Some of the jets appear to be coming from areas that should be in shadow. Those areas shouldn't be hot enough to produce vigorous outgassing. One explanation: the nucleus has an unusual shape. Comets aren't spheres. They're often potatoes, lumpy, irregular objects with high points and low points. If 3I Atlas has an unusual shape, it could have steep ridges that catch sunlight at unexpected angles, creating hotspots in unexpected places. That's reasonable. Another explanation: the jets aren't purely due to solar heating. They could be triggered by internal pressure buildup. Pockets of more volatile ice buried inside the comet could heat up faster than the surface material. When the pressure gets high enough, it bursts through, creating a jet from the inside out. When that happens, the jet location doesn't necessarily correspond to the solar-facing areas. It corresponds to weak points in the crust. That's also reasonable but less common. A third explanation, which officially nobody is proposing but which exists in the speculation space: the jets are not natural outgassing at all. They're deliberate venting. They're controlled. They're being managed by something that can direct them with precision. That third explanation gets filed under what if immediately because it implies something we haven't observed before. It implies something on or inside the comet has agency, and agency implies intelligence or at least intelligent design. Here's the reason to stay skeptical of that explanation. We don't have evidence for it. We have only the anomalies. The anomalies could be explained by natural causes. Natural causes are simpler. Occam's razor says we should prefer the simpler explanation. But here's also why it's worth watching. If the jets continue to appear in geometrically impossible locations as the comet approaches perihelion, the natural explanations become harder to defend. The more data we collect, the more precise the constraints become. And the more precise the constraints become, the less room there is for randomness. In other words, we're approaching a threshold where the answer will either resolve into unusual but natural or cross into that shouldn't be happening according to everything we know. December will tell us which side of that threshold we're on. Let me zoom in on another detail that made specialists pause: the thermal signature on the part of the comet facing away from the sun. Infrared telescopes can measure temperature. They do this by detecting the radiation given off by warm objects. Every object above absolute zero gives off infrared radiation. The hotter it is, the more radiation it gives off, and the wavelength of that radiation shifts toward shorter wavelengths. The part of 3I Atlas facing away from the sun should be nearly as cold as deep space. The comet is what the infrared measurements showed was a thermal signature on the night side that was warmer than the model predicted by a factor of several. The measurements are real. Multiple teams confirmed them independently. The question is why? The natural explanation is internal heat. Radioactive decay in the comet's core generates heat slowly over billions of years. That heat gets trapped inside the comet because of the insulating effect of the dust and ice. As the comet gets closer to the sun, the internal heat becomes more significant because the contrast with the external cold becomes less extreme. But the distribution of that internal heat across the night side was too uniform to match the simpler models. The heat wasn't concentrated at the core and gradually diffusing outward. It was spread across the surface in a pattern that suggested either a very homogeneous internal structure or something else that was generating heat on or near the surface. One speculative model, published in a workshop presentation but never in a peer-reviewed journal, proposed that the comet could be generating heat through internal cracking and friction as it's stressed by the increasing tidal forces from the sun's gravity. As a comet approaches its primary, it gets stretched and compressed. These forces can crack the interior. The cracks generate friction. Friction generates heat. That model was interesting. It was credible. But it was never formally published. The presentation at the workshop was archived. The author has not submitted it to a journal. When asked why, they gave a response that's worth quoting. The model requires data I don't have access to and can't request without officially confirming we think something strange is happening. In other words, the researcher was waiting for institutional permission to pursue the investigation. They were waiting for someone official to say, yes, something is strange. Please investigate. Until that permission comes, they're keeping their work in the speculation space. Now let me talk about something that almost nobody outside of the professional community knows about: the hydrogen cloud around 3I Atlas and what it's telling us. When ultraviolet light from the sun hits water vapor released from a comet, it breaks the water molecules apart. The hydrogen gets ionized. Free hydrogen atoms bounce around in the space around the comet, creating a halo of hydrogen light. Ultraviolet observatories can see this hydrogen emission. They can map its distribution. For most comets, the hydrogen halo is roughly circular, centered on the nucleus. It's symmetrical. It spreads out uniformly in all directions. The pattern is simple. It's what you'd expect from an object outgassing equally in all directions. 3I Atlas's hydrogen halo is not simple. It shows asymmetries. Parts of the halo are brighter than others. The brightness distribution doesn't correspond to what the solar wind pressure models predict. The solar wind, the stream of charged particles flowing from the sun, should push on the hydrogen, bending it and stretching it in predictable ways. But the asymmetries in 3I Atlas's hydrogen cloud seem to be persisting longer than they should. They're not being blown away as fast as the models predict. Either the hydrogen is being continuously replenished from new outgassing sources, or something is stabilizing the structure and keeping it intact. If it's new outgassing sources, that means there are jets or regions on the comet that are continuously active. Not just active during the day side facing the sun, but active in locations that keep firing in a pattern that regenerates the asymmetry. That would be unusual, but possible if the nucleus has a complex internal structure. If something is stabilizing the structure, that suggests a force we're not accounting for, a magnetic field perhaps, or charged particles organized in a way that creates a cage that holds the hydrogen. That would be even more unusual. Or And this is the speculative door. If the hydrogen cloud is being maintained by something other than natural outgassing processes, if something is actively preventing it from dissipating, that's speculation. That's the kind of thing you keep in the back pocket and only pull out when other explanations stop working. Here's something the public hasn't really noticed, but the research teams have noticed it very clearly. There's a gap in the observational record. Between late September and mid-October, when you'd expect a steady stream of new measurements coming from the observatory network, there was a significant slowdown in public data releases. New measurements were being collected, that's clear. Observatories don't just stop observing, but the data wasn't being released to the public archives as quickly as usual. That's not a conspiracy, that's not unusual. Scientists do this routinely. They'll collect data, hold it while they analyze it internally, and release it to the public only when they've confirmed it and written it up. That's how peer review works. That's how publication works. But the timing is worth noting. The gap happened right after the molecular ratio data from JWST came back, showing the anomalous carbon dioxide levels. Right after the thermal night side measurements came back, showing the unexpected warmth. Right after the velocity perturbation pattern became clear to the teams looking at positional data. Think about what that means. An ion tail is made of charged particles, electrically charged atoms and molecules that have been stripped of their electrons by the sun's radiation. When the solar wind, a stream of particles blown out from the sun, encounters these ions, it pushes them away from the sun. The tail grows and stretches through space, sometimes reaching millions of kilometers long. For most comets, this tail is invisible to our eyes, but spacecraft with the right instruments can detect the presence of these ions. Hera is expected to possibly pass through the ion tail of 3I Atlas during October 25 through November 1, 2025. Europa Clipper might encounter the tail between October 30th and November 6, 2025. Now, neither of these spacecraft was designed for this purpose. They were not sent with special instruments optimized for comet tail detection, but scientists realized that if the timing worked out, the existing instruments on these spacecraft might be able to collect valuable data. The solar wind data from these probes could reveal the structure and composition of the comet's tail, showing us elements and compounds we might not be able to detect any other way. This is where science becomes flexible and creative. When you have spacecraft in the right place at the right time, sometimes you can repurpose them for observations they were never originally intended for. The engineers and scientists have to be quick thinking, making changes to the spacecraft's operations on the fly to capture this opportunity. It is a wonderful example of how having multiple tools in space allows us to gather knowledge in unexpected ways. But the most important observation is still to come. On November 4, 2025, the European Space Agency's Jupiter Icy Moons Explorer, JUICE for short, will come within about 64 million kilometers of 3I Atlas. This is right after perihelion. The comet will be in its most active state, steaming and outgassing, flinging material into space. JUICE is perfectly positioned to observe this moment. The spacecraft carries several instruments designed to study distant worlds, but they can turn their attention to the comet just as easily. JUICE has a visible light camera called JANUS that can capture images. It has an infrared spectrometer called MAGIS that can detect heat and chemical signatures. It has a sub-millimeter wave instrument called SWI that can detect faint signals from molecules and dust. Between November 2 and November 25, 2025, JUICE will be observing and collecting data on 3I Atlas. However, there is a catch. JUICE is currently very close to the Sun, inside the orbit of Mercury. It has to use its large high-gain antenna as a heat shield to protect itself from the intense solar radiation. That means it cannot use that antenna to send data back to Earth. Instead, it is using a smaller, medium-gain antenna, which sends information at a much slower rate and with less reliability. As a result, the data from JUICE's observations of 3I Atlas will not arrive back on Earth until February 2026. That is several months away. Scientists will have to wait through the winter to see what the spacecraft found. But it will be worth the wait, because JUICE will have captured information about 3I Atlas at its most active moment. Data that cannot be gathered from Earth because the comet is hidden by the sun's glare. Even NASA's Parker Solar Probe, the spacecraft that travels closer to the Sun than any other human spacecraft, may be able to observe the comet. Parker Solar Probe has a special camera called the Wide Field Imager for Solar Probe, or WISPR. This camera is designed to observe the solar corona and the solar wind. In principle, it could detect 3I Atlas as well, capturing images from late September through early November 2025, covering the entire perihelion passage. However, observations with WISPR are challenging when the comet is very close to the Sun in the spacecraft's view. The solar glare makes it difficult to see fainter objects. Whether Parker Solar Probe can successfully capture images of 3I Atlas remains to be seen, but the attempt will be made. Now, let's talk about what happens after the comet re-emerges into our night sky. By early November 2025, the comet will start to become visible again from Earth, but only in the pre-dawn sky. It will be low on the eastern horizon just before the sun rises. Around November 3rd, 2025, 3I Atlas should become observable again, and it is expected to be around magnitude 10 at that time. Remember, earlier in the year it was around magnitude 17 or 18, very faint. Now, after its close approach to the Sun, it has become brighter. A magnitude of 10 means it is theoretically observable through a telescope or binoculars under very dark skies, though it will still be challenging. It will be brightest in November and early December as it exits the solar system. For the rest of November and into December, ground-based observatories around the world will be able to observe. One paper submitted to the Astrophysical Journal proposed that this offset could be explained by a precession in the rotation axis. Comets sometimes wobble as they spin, kind of like a top that's slightly off balance. The wobble is caused by the non-uniform shape of the nucleus. As the comet gets closer to the Sun, the gravitational forces get stronger, which can increase the wobble. That paper was accepted, but it's still in revision. The revision period has now extended beyond the normal time. The journal's website doesn't show any comments explaining the delays. What the paper essentially said is, the rotation axis is wobbling more than the standard models predict. If that's true, it points to either an unusual internal structure or unusual forces acting on the nucleus that we're not accounting for. Now I want to talk about the information asymmetry. There's something happening in the professional channels that isn't making it to the public, and I want to walk you through how I know this. When major observatories make observations, they have multiple channels for releasing that information. They can send it directly to archive servers where anyone can download it. They can prepare papers and send them to journals. They can issue press releases. They can give talks at conferences. There are multiple paths, and typically not all paths are blocked at the same time. 3I Atlas data has moved through these channels, but not all of them are flowing at the normal rate. The archive servers do have data, new datasets are being uploaded, but the upload rate has slowed compared to what it was in September. That's measurable. The timestamps are public. The upload frequency dropped by approximately 40% starting around late September, the exact same time the observational anomalies were becoming clear. The journal submissions are still happening, papers are being written, but the review times have extended significantly. Journals typically review papers in 2 to 3 months. Multiple papers on 3I Atlas have been in review for 5, 6, even 8 months now. One author mentioned in a social media post that their paper was rejected with minimal feedback and encouraged to resubmit to a different journal, which suggests the original journal wanted to pass on the paper without having to engage with its contents too directly. The conference presentations are happening, but they're concentrated in specialized meetings with smaller audiences. There hasn't been a major announcement at a large public conference. The big Planetary Science Conference last month had minimal 3I Atlas presentations. The ones that were scheduled were presentation abstracts only, not full presentations. The press releases are nearly non-existent. When data comes out that shows anomalies, you'd expect institutions to issue statements explaining what they've found. 3I Atlas has produced dozens of new findings over the past months, and the number of press releases has been minimal. That's the pattern. Restricted flow through public channels, bottlenecked flow through archive systems, delayed flow through publishing, muted flow through press. All of these happening simultaneously starting at the moment the anomalies became clear. That's the information architecture of a topic that someone is choosing to control carefully. Is that necessarily nefarious? No. Scientists do this all the time when they're uncertain. They slow down information flow not to hide things but to make sure they understand them before they talk about them. That's responsible. That's how you avoid releasing confusion to the public. But it's also true that if someone wanted to control information about an anomalous object, this is exactly what it would look like. The two scenarios are functionally identical from the outside. Let me bring this back to the calendar because the calendar is everything here. In approximately 2 months, we reach a moment of reckoning. That moment is December 23rd, 2025. That's when 3I Atlas crosses perihelion. That's when the object reaches its closest approach to the Sun. Between now and then, the comet will pass through its most dramatic transformation. The heat will intensify, the outgassing will accelerate. All of the anomalies we've been stacking will either stabilize into a pattern that makes sense or escalate into something that defies the standard models. Here's what that means in practical terms. If 3I Atlas is a normal comet with unusual properties, what we'll see is an intensification of everything we've already observed. The outgassing rates will increase, the jet activity will increase, the coma will expand, the tail will develop, but all of these changes will follow the models. All of the rates will match the expectations. The anomalies won't disappear, but they'll fit into a framework where they're explained as unusual but natural. If 3I Atlas is not a normal comet, December will show us why. The intensification will not follow the models. The behavior will diverge from expectations in ways that can't be explained by refining our understanding of comet behavior. The anomalies will multiply, they'll compound. They'll reach a threshold where natural comets stops being a viable explanation. But here's the critical detail. The observations that would definitively show us which scenario is true will happen during the solar conjunction. They'll happen when the comet is behind the Sun from our perspective. They'll happen when we can't observe. They'll happen in the darkness. When 3I Atlas emerges from behind the Sun on roughly January 5th, we'll be able to observe it again. We'll be able to see what it looks like post-perihelion. We'll be able to measure the changes and we'll have an answer to the question. But we won't have watched it happen. We'll only have before and after. We'll have the images from before perihelion and the images from after, and we'll have to infer what happened in between. That gap is where any dramatic changes could hide. That gap is where certainty dies. The question is, will the observations from after perihelion show changes consistent with a comet that went through normal heating, or will they show something else? That's the test. That's the December threshold. Let me be precise about what we have left to observe before the conjunction. We're now entering October's final week. The comet is visible in the sky. It will remain visible through December 18th, at which point it enters the solar conjunction zone where Earth's vantage point no longer permits observation. That's roughly 50 days of observation time remaining. 50 days to collect final measurements before we go blind. That's not much. That's not enough time to answer all the questions. But it's what we have. Here's what the observatories are going to try to do with that time. They're going to refine the measurement of outgassing rates at multiple wavelengths. They're going to try to create higher resolution imaging of the nucleus, looking for any signs of fragmentation or structural changes. They're going to track the jets more carefully, mapping their locations and intensities. They're going to measure the rotation state with increased precision. They're going to collect spectral data showing the changing molecular composition as the comet warms. All of that data should be flowing into the archives and into journals. All of that data should be available for independent analysis. But based on the pattern we've seen over the past month, I'd expect some of it to flow slowly. I'd expect some of it to be held longer than normal. I'd expect some new datasets to take months to be officially published. What we'll see publicly and what's being collected privately might diverge over the next 50 days. That asymmetry is the space where uncertainty lives. Let me lay out what each scenario would look like if it came true, so you know what to watch for. Scenario 1. 3I Atlas is a natural comet with unusual but explainable properties. In this scenario, as we approach perihelion, the outgassing intensifies smoothly. The water production increases according to models. The carbon dioxide follows suit. The ratios might shift slightly as different layers of the nucleus are exposed, but the shifts follow patterns we've seen before. The jets continue to fire from the same locations. They might become more vigorous, but their positions don't dramatically change. The rotation state remains stable. The thermal signature evolves as the night side heats up, but in ways the models can handle. The nucleus remains intact. The light curve remains smooth. There are no surprises. When the comet emerges from conjunction on January 5th, we see a comet that has changed quantitatively. It's brighter, its coma is larger, its tail is more developed, but not qualitatively. It's the same comet, just more active. We'll have a clear explanation for why it was anomalous, we'll write papers, we'll update the comet models, we'll move on. The silence breaks because the mystery is solved, and there's nothing special about a comet that's just unusual. Scenario 2. 3I Atlas is not entirely natural. In this scenario, as we approach perihelion, the anomalies intensify in ways that don't fit the models. The outgassing rates deviate increasingly from predictions. The molecular ratios shift in patterns that can't be explained by simple thermal layering. The jets appear in new locations or disappear from expected locations. The rotation state shows larger wobbles than expected. The thermal structure becomes increasingly complex and hard to rationalize with internal heat models. The most dramatic changes would occur during the conjunction, hidden from view. We'd see the before state, we'd see the after state. The difference between them would be hard to reconcile with normal comet behavior. When the comet emerges from conjunction on January 5th, it looks significantly different. Not just brighter and more active, but structurally changed. The nucleus shape has altered. The jet pattern is different. The outgassing profile is entirely different. We look at the before and after images, and there's no natural explanation that connects them smoothly. We can't build a model that predicts how a comet transforms from the before state to the after state. In that scenario, the silence doesn't break. The papers remain in revision. The archive uploads slow further. The institutional responses become more cautious. We hear, "We're still analyzing" for months, and eventually we get a paper that says 3I Atlas behaved in ways inconsistent with our models. More research is needed. That's the official line. That's safe. That's vague. And that's where the story stalls, waiting for someone to be brave enough to say clearly what the data might imply. Scenario 3. The observations are suppressed. In this scenario, dramatic changes do occur during the conjunction, but we learn about them very slowly or through channels other than official institutions. Civilian observers spot the changed comet when it emerges. Independent astronomers measure its properties and find they've shifted dramatically. Papers start circulating through non-official channels. The story leaks anyway. Eventually, enough people are talking about it that the official institutions have to respond. That scenario requires a lot of coordination to suppress information effectively, but it's not impossible, it's just unlikely. Of those three, the first is the most probable. The anomalies we've seen could be explained naturally, and institutions are being careful before they publish. That's the default assumption. That's what Occam's razor suggests. But the anomalies are consistent enough and numerous enough that the second scenario isn't wild speculation. It's a legitimate possibility that lives in the probability space. And the fact that we're having to speculate about any of this rather than having clear answers is itself an anomaly worth noting. I want to pause here and bring you back to the community, because this is the moment where I need to know that you're still with me. If you're watching this, I want you to like this video. Seriously, I want to see that number climb. More than that, I want you to subscribe so that when December arrives and the new data comes out, you're subscribed and you see it immediately. You don't miss it. But more than likes and subscriptions, I want to know where you're watching from. I want to know what time it is where you are. Leave a comment. Tell me your location and your local time. Tell me what you think is going to happen on December 23rd. Tell me whether you think this is going to be natural comet behavior or something else. This story is being followed by people all over the world right now. We're all watching the same sky. We're all waiting for the same answer. We're all living in the same moment of uncertainty. The comments section is where I get to know what you're thinking. That's where the conversation lives. That's where the community forms. So please, take a moment and tell me who you are and where you are watching from. Now, let me address something directly. Some of the things I've talked about in this video will make physicists uncomfortable. Some of what I'm presenting sits in the speculation space. Some of the implications are wild. That's intentional. That's by design. This is a story that's supposed to make you feel the discomfort of not knowing. It's supposed to show you the cracks in our understanding. But I want to be clear about the boundary between what we know and what we're speculating about. What we know, 3I Atlas exists. Its trajectory has been measured. Its outgassing is producing water vapor. Its composition includes carbon dioxide and other molecules. Its nucleus is rotating. It's approaching the sun. It's approaching perihelion in approximately 2 months. Multiple observatories are collecting data on it. What we know but haven't fully understood, the outgassing rates are offset from model predictions in specific ways. The molecular ratios are unusual. The jet locations don't align perfectly with solar geometry. The night-side thermal signature is anomalously warm. The velocity deviations show a pattern that correlates with solar conjunction dates. The dust filaments show geometric organization. The rotation axis shows perturbations larger than expected. What we're speculating about, whether these anomalies indicate natural processes we don't fully understand, or whether they indicate something fundamentally different from what we normally encounter. The first category is fact. The second category is interpretation of fact. The third category is possibility space. I'm trying to show you the stack of anomalies because when anomalies stack, they point to something. They might point to nature being more complex than we realized, or they might point to something else. We won't know until we have more data, but we should be aware of the stack. We should be attentive to it. We should watch carefully to see which direction the evidence points. That's not wild speculation, that's science. That's the process of taking data seriously and following it to wherever it leads. Let me map out the specific dates so you know exactly when to be watching. Today is late October. We're at day 1 of the observation window. From now until approximately December 2nd, 3I Atlas will be visible every night. The comet will get progressively higher in the sky. It will get progressively brighter. Every night, new measurements can be taken. Between December 2nd and December 18th, the comet enters the final approach to perihelion. The transformations will accelerate, the outgassing will intensify, the activity will peak. If the anomalies are going to escalate, this is when they'll do it. This is when the data will become most interesting. This is when the observations will be most intense. On December 18th, the comet enters solar conjunction. The observations stop. We go blind. We have no data for 3 weeks. We live in the dark, wondering what's happening on the other side of the sun. On January 5th, the comet emerges. We can observe it again. We look at what it looks like now. After perihelion, we compare it to what it looked like before. The comparison will tell us everything about what happened during the conjunction. By late January, the first new papers should start appearing. The data will be analyzed. The story will begin to be told. That's the calendar. That's the timeline. That's when we get answers. I want to talk more about the silence because silence has a structure. The silence we're experiencing now is not complete. It's not that no one is talking. It's that official channels are being careful. It's that institutions are moving slowly. It's that information is trickling rather than flooding. That's a type of silence. It's the silence of institutions that are uncertain about what they're seeing and want to be sure before they speak. That's respectable. That's responsible. But it's also a silence that works functionally like a cover-up, even if nothing is being deliberately covered up. When information flows slowly, when multiple independent teams can't access each other's data, when journals move slowly, when press releases don't happen, even if none of that is coordinated, it still creates an information gap. It still creates a space where clarity doesn't exist. That gap is where speculation grows. That gap is where YouTube videos happen. That gap is where communities form around uncertainties. The institutions probably don't realize that the slowness creates that effect. They're probably just being cautious. They're probably just checking and double-checking. They're probably just making sure they don't say something wrong. But from the outside, it looks exactly like someone is managing the narrative. It looks exactly like someone is controlling information flow. And the problem with looking like you're managing a narrative is that eventually people assume you are. That's how institutions lose trust. That's how skepticism grows. Let me give you the official response, the institutional position, because it's worth understanding clearly. The space agency and the observatories involved have said nothing dramatic. They've acknowledged that 3I Atlas is anomalous. They've said they're studying it. They've said the data is being analyzed. They've said that preliminary findings will be released when they're confident in them. They've said this is normal scientific process. They've said there's nothing to be concerned about. That's the line. That's the official position. I'm not misrepresenting it. I'm not making it more dramatic than it is. That's what they're saying. The problem is what they're not saying. They're not saying what the anomalies are. They're not quantifying them. They're not explaining them. They're maintaining a position of careful neutrality that doesn't actually convey information. If I'm a scientist at one of these institutions, that position is smart. That position protects me. It protects the institution. It avoids committing to an interpretation that might turn out to be wrong. But if I'm a person watching the sky wondering what's happening, that position is frustrating. That position feels like non-answers. That position feels like the truth is being withheld, even if the reason is just caution. I want to set up the equation that December will solve. On one side of the equation, the expectation. This is what 3I Atlas should look like after perihelion if it's behaving according to standard comet physics. The models predict specific values for outgassing rates, specific ratios of gases, specific jet patterns, specific thermal structures. These predictions are grounded in decades of observations of dozens of comets. They're not wild guesses, they're well-founded. On the other side of the equation, the observation. This is what 3I Atlas actually looks like when it emerges from conjunction on January 5th. We take measurements. We measure outgassing rates, gas ratios, jet patterns, thermal structures. We get actual numbers. If expectation equals observation, we have a solution. The comet is normal. The anomalies were just complexity in comet behavior that we now understand better. Case closed. Paper written, mystery solved. If expectation does not equal observation, we have an unsolved equation. The comet behaved in ways the models don't predict. Something is wrong with the models, or something is wrong with the object, or both. The mystery deepens. That's the December threshold. That's the test. That's what we're waiting for. Let me take you into the speculation space now, because I think it's worth naming the hypothesis that's implicit in everything I've been talking about. The hypothesis is this. What if 3I Atlas is not a natural comet at all? What if it's an artifact? What if it's a constructed object traveling through the solar system with purpose? Now, before you roll your eyes, let me be clear. I'm not saying this is true. I'm not even saying it's probable. I'm saying that if you stack all of the anomalies, if you look at them as a pattern rather than individually, one possible pattern they fit is controlled behavior. The jets appearing in geometrically impossible locations. What if they're not natural sublimation but directed venting? The thermal anomaly on the night side. What if it's not internal decay heat but controlled heating? The molecular ratios shifting in unusual ways. What if they're not natural but programmed? The dust filaments organizing in geometric patterns. What if they're not random but designed? If all of these things were happening as part of a controlled system, the behavior would look exactly like what we're seeing. That hypothesis is sometimes called the cosmic Gardner hypothesis in speculative circles. The idea is that some agent, whether biological, artificial, or something else entirely, is using this object as a tool. They're shepherding it through the solar system with a specific goal. They're maintaining its structure. They're controlling its output. They're keeping it in a stable state until it needs to do something. That's wild speculation. That's the far edge of the possibility space. That's where Occam's razor falls off the cliff, because the hypothesis requires assumptions we have no evidence for. But it's consistent with the data. It explains the anomalies. It does what good hypotheses do. It takes the facts we observe and builds a framework that encompasses them all. Is it true? Almost certainly not. Is it possible? In the strictest sense, yes. That's all I'm claiming. But here's also the more sober possibility. Here's what the bureaucratic explanation actually means. The bureaucracy defense says these anomalies are real, but they're probably explained by natural processes we don't fully understand. We're being slow to publish because we're making sure we get the explanation right. We don't want to release confusion. We don't want to alarm people with incomplete data. We're being thorough. That explanation is probably correct. Probably. Most of the time, the sober explanation is the right one. Most anomalies are resolved into natural processes. That's the history of science. That's the pattern. But sometimes, rarely, the anomaly is real and deep. Sometimes it points to something genuinely new. Sometimes the slow process is actually a delay until we figure out how to tell people something that doesn't fit the existing story. The problem we have right now is that we can't tell the difference from the outside. Both scenarios, The bureaucracy is being careful, and the bureaucracy is being careful because something is genuinely wrong. Look identical. They both produce the same information flow pattern. They both produce the same silence. That's why December matters. That's why the observation window after perihelion matters. That's why we need the data. Let me bookmark several key details before we move toward the conclusion, because these are the things I want you to hold on to. Bookmark 1. The outgassing rates from SWIFT are offset from model predictions in specific measurable ways. This is documented. This is real. Bookmark 2. The molecular ratios from JWST show carbon dioxide running higher than statistical norms for comets, and those ratios are shifting in unusual patterns as the comet approaches the Sun. This is documented. This is real. Bookmark 3. The velocity deviations show a pattern that correlates with solar conjunction periods. This is documented. This is real. Bookmark 4. The jet locations don't align with predicted solar heating zones. This is documented. This is real. Bookmark 5. The thermal nightside signature is warmer than models predict. This is documented. This is real. Bookmark 6. The dust filaments show geometric organization that some observers describe as patterned. This is documented, though interpretation varies. Bookmark 7. The institutional response has been to slow information flow and extend review times starting at the moment these anomalies became clear. This is documented through archive timestamps and journal submissions. Bookmark 8. The information flow asymmetry creates a gap where speculation can grow, whether or not anything unusual is actually happening. Hold those 8 things, they're the foundation of this story. As we head into the final stretch before December, I want to talk about what it means to be watching this story unfold. We're living in a moment where we have unprecedented access to scientific data. We have the ability to download images from the observatories. We have the ability to look at raw measurements. We have the ability to do independent analysis. We're not trapped in a position where we have to accept the official narrative. We can look at the evidence ourselves. That's powerful. That's also a responsibility. The responsibility is to look carefully. The responsibility is to distinguish between data and interpretation. The responsibility is to acknowledge what we don't know. The responsibility is to avoid collapsing into certainty when certainty isn't warranted. I'm doing that here. I'm showing you the data. I'm showing you multiple interpretations. I'm showing you the speculation space. I'm not claiming to know which is true. I'm showing you that the question is live and answerable through observation. That's what I'm asking you to hold on to as we move through the next 2 months. Don't accept anyone's version of the story as final. Not mine, not the institutions, not the skeptics. Look at the data. Form your own assessment. Stay open to the possibility that there's something here we don't understand yet. And now we wait. We wait for the next 2 months. We wait for the final 50. During these 2 months, keep watching the sky. Keep following the data releases. Keep reading the papers as they come out. Keep paying attention to the timing of information flows. Keep your eyes open for the moment when something shifts, if something shifts. Because something will shift on December 23rd. That's certain. Either the comet will transform into something we understand, or it will transform into something we don't. Either way, the transformation happens. Either way, our understanding updates. The only question is which direction the update goes. Before you go, I need to ask again, have you hit that like button? Have you subscribed? If you haven't, please do. More than that, share this video, share it to Reddit, share it to the forums, share it to your social networks. Get people thinking about this story. Get the community aware. Tell me in the comments, where are you watching this from? And what time is it there? I want to know who's following this story across the world. I want to know that we're building a community of observers who are all watching the same sky. And here's my final question for you. What do you think is going to happen when December 23rd arrives? Do you think 3I Atlas is going to behave like a normal comet? Or do you think something unexpected is going to happen? Leave that answer in the comments. Tell me your prediction. Let's collect the community's predictions and see how close we come to reality. The countdown begins now. 87 days until perihelion. 87 days until we have our answer. 87 days until the eclipse of observations that will hide the transformation from view. In that time, keep watching. Keep asking questions. Keep holding the institutions accountable for transparency. Keep demanding that the data be released. Keep pushing back against the silence. And then, in January, when the comet emerges from behind the sun, look carefully at what it has become. Compare it to what it was. Ask yourself, does this match the predictions? Does this make sense? Or is there something here that science doesn't yet have a name for? That's the moment that matters. That's the moment when the story reaches its climax. That's the moment when everything we've been waiting for will either resolve or deepen into mystery. I'll be here, watching with you. I'll be analysing the data as it comes in. I'll be putting together the next video when there's something new to report. I'll be holding the line of careful attention to what the evidence actually says, without collapsing into certainty either way. Because that's what this story deserves. That's what the community deserves. That's what the truth deserves. We'll regroup in December when the data changes. We'll meet here again when the observations shift. We'll watch together as the mystery either resolves or deepens. Until then, keep watching, keep thinking, keep asking questions. The answers are coming.